go with you guys uh, through some serverless integration patterns and manage the services that we didn't present to you yet in AWS. And thanks very much for joining this class. It's the last class that we share contents with you. We are still going to work with you uh, to answer any question related to exercise or any problem that you have at work and you need to discuss solution, clouds, anything. Um, but formally, the class content, it is the last one. And there are a couple of exercises following this one that I'll ask one or two of you to present what we've done in the next class quickly. It's just an exercise, but it is a continuation from the class 6 exercise. It is a nice solution to see working and see it running. So probably I'll ask one person just to show how they have done it. So in this class, I'll present you some integration patterns. And integration patterns usually are needed when you need more than one system to communicate, right? Or service. If you're from a development background, probably you've done lots of service integrations. And you've worked with APIs, synchronous, asynchronous integrations, pub sub, push and pull, and so on, depending on the requirements. And I'm not going to show an extensive list here because that's not the intention, and neither asking you guys to develop a lot of code in whatever language. Yes, there will be some development required in these exercises, and I'm not talking about languages here specifically, so just feel free to go ahead. I'm going to focus on the pattern itself and AWS services mainly, how to solve the problems with AWS services. So starting here, the first one we are going to see is one that if you've done the first exercise for serverless, it was about exposing an interface so a client could consume a service. And for this problem, we solved using the API gateway. The API gateway, it's an orchestration pattern. It's not only an AWS service. There are lots of products out there, commercial products that you can use. And here specifically, we are talking about REST APIs to solve this integration. But if you're more old school, or if you have high performance requirements, probably you need to do some other kinds of remote procedure invocation here. It's the same pattern. You need to expose an interface. As you can see here, it's the API gateway in this case. And on the right-hand side, a service addressing the request. So the only thing, probably you've known this pattern. The only thing that I'd like to add here is that you can use a variation of this pattern called robust APIs. It has several names, right? But basically, by choosing different routes, you can, using your API gateway, not only for proxying your requests, but also for routing to different systems like legacy systems. Um, it is possible to create specific routes with different targets, not only in the AWS API Gateway service in AWS, but also using the application load balancer. If you remember from your project, there you can define routing rules, and you'd achieve similar benefits. Of course, in API Gateway, you have more features. You can do caching and other stuff. But, well, you may reduce your cost using the ALB as well. So just to think about it, if you want to implement this pattern, routing per resource, think about the ALB and the API Gateway services. Moving on from this pattern, there's a famous pattern called Strangler pattern. And it is famous in the microservices world because the first question when you think about microservices and you look ahead and think, okay, let's do this new cool thing that is complex, but I really enjoy doing. But on the left-hand side, you look at your legacy system and think, okay, how can I migrate this bunch of stuff to this new architecture? So architectural refactorings are not easy usually, and they usually bring a lot of risk to the business. And that's why they're hard to justify as well. So usually you need some kind of non-functional requirements coming from the business. For example, the response time is too high. The customer cannot afford 5 seconds response time to deliver the response to the customer, aka Azure Portal. Just joking. And if you have this kind of NFRs, probably just look at your business rules, you won't be able to solve it unless it was bad coding that caused the problem, right? But just thinking the business rules might not solving the problem, so you might need to refactor the solution. So the Strangler pattern comes to help you migrate parts of your business application while keeping the legacy system running in a seamless way. And this way you can validate smaller parts of the system before, well, decommissioning the legacy system at all. So as you can see here in this diagram, we have a load balancer. You can say again, okay, could it be an API gateway? Probably, because we are going to use the same technique that we used here. We are going to route the requests based on the resources, right? But as you're just proxying the request, right? You don't need to do transformation caching here. The load balancer would be enough. And I'm saying here that if the request is for the resource orders, then it should route to a microservice to treat orders, which in this case is just a Lambda and Dynamodb. And all of the other resources should be routed to the legacy system. Of course, the legacy system here might be using other data stores, right? And for doing this synchronization back to the legacy system, you can leverage the Dynamodb Streams, and we are jumping to it in a minute, which is basically a time series of changes in your DynamoDB that you can forward in an ordered manner to a Lambda function to handle. And in this Lambda function, you can do anything you want. In this case, by consuming from this stream, I'm synchronizing back the data needed for orders in the legacy system. As you can see, this is an eventual consistency flow. So the data about orders will be there in the legacy system. Eventually, it will be there, right? It's not a synchronous flow. But if you can afford eventual consistency, and at first you might think that you cannot afford it, I think it's part of changing the mindset a little bit about the architecture. But if you reconsider that, you'll see that most of the cases we can afford this eventual consistency. There's no problem of not having the data synchronized for 1 second, let's say, or less than that. We cannot lose data. That's the main thing, right? So if this process is running well and your Lambda is not failing, it's synchronizing okay, that's all right. If your Lambda fails, then we'll need to apply other patterns that I think I put here. So that's basically the strangler pattern. We start migrating just one function, then it grows, it grows, it grows, it grows, until you'll have like 90% of your functions running as independent microservices and just 10% in the legacy system, and you decide to fully go away from the legacy system. Of course, I'm assuming here it's a web service, right? It uses routes. So yeah, that's the context, right? So what is DynamoDB Streams? And from the patterns, I'll jump into the technology a bit, just to give you more details, how you can use it. So you can have this stream of changes in your table, and it holds this data up to 24 hours. It is ordered. It is not duplicated. And it guarantees that it will deliver just once to your Lambda. In practice, let's jump into the console. I'm opening here the DynamoDB service. Let me see if I have a table here. Yeah, I do. Let me get, yeah, this one does the job. So here's my table. I think it's a table. It doesn't have anything special. I'll just use it for test. And the first thing you can see here is stream enabled? No, right? So the first thing you need to enable the streaming in your table, and there will be 4 options there for you. He's going to ask you, do you want to just know the changes by the keys? So I'll pass just the keys for you, right? This is the first option. If you have, you remember the partition key and the sort key. The partition key is like the primary key, and the sort key is like a composite key for ordering the data in Dynamo. It will give you just these keys. So depending on what you're doing, you need to go back to Dynamo, do a query, to understand what happened with the data. Second option, you can get the new image. It means the new version of the item. Remembering that one item is one row in the DynamoDB table. So it will give you just the new one. Old image, just the old item, and new and old images, it will give you both. So you can do a comparison and identify what changed. It won't give you exactly what changed. It won't say the name changed from Dennis to Jose, for example. So usually if you need to compare these old and new items, you'd grab this last option, new and old images. So let's go ahead and enable it. Right, so my stream is being applied right now, just finished. Cool, all right. So if I come right now and create a new item here, let's use Jose again. I think timestamp is a stored key. So let me just input same thing here. So this new record that I just created, it was captured in the stream. But at this point in time, I didn't tell DynamoDB to do anything with my stream. It's just running. It's aggregating the changes, but there's no Lambda consuming from it. So you need to come here to the triggers in this table and configure a new trigger. A trigger will connect the stream to a Lambda function. And Lambda is your only option here. You cannot stream DynamoDB changes to SNS directly or SQS. Yeah, you cannot do it. That would be useful. I'm just thinking about another pattern. Maybe it would be useful for the publish subscribe pattern or in an event-driven architecture, right? But it's just Lambda. So let's grab an existing Lambda. This DOA one. And here's the batch size. So depending on the volume you have of changes in your table, there might be a slight delay before calling your Lambda. So basically the batch size will tell how many records you want to grab from this stream at one time. So if you always want to pick one record at a time, then you'd use one. But usually it happens so fast. It depends on your volume, really. Depends on your scenario, right? But usually it's good to have a high number here, like 100, for example, and you iterate in your function and you do the work you need to do for all of the stream records that you grabbed, just for avoiding calling the Lambda again, invoking the Lambda again. It might not be that efficient if you do like with one batch of one. So let me just enable it. And that's basically it. Let me open the function, lambda. that would be good if I could show you what a record looks like. Well, I think for the console, I'm just checking the permissions for this. Yeah, it doesn't seem it added any special permission for the stream. Let's see how it goes. I'll create a new item. Now, in fact, I'll change this item here. From Jose to Dennis. I'll open the CloudWatch logs. Yes, that's our log. Yeah. So in the start of my Lambda, I'm basically printing the event I received. The way it came, I just printed it. And here's the record from the Dynamodb stream. So you can see event source, Dynamo, records, and it is an array. It could have returned more than one. Event ID, every event you'll see here will have a unique ID. And yeah, here you can see keys. If you want to do some other processing and you need to fetch the item again in the table or just go back and update it, you have the keys easily here. New image is the new item. So you can see Dennis in the name, and old image, Jose. So right now it's my Lambda. I received this payload with exactly the old and new images from Dynamo. So from here, you can do whatever the logic you need to do. It's very powerful. Any questions up to this point?
That's really cool.
Yeah, it is, isn't it?
Yeah, I need to play with it.
Yeah, it's very cool. It's yeah, I hope, let's see how we go with time, but I'd like to reserve 30 minutes so we can discuss maybe use cases that you have and how we could apply these patterns I'm going to present. But let's go forward. I don't want to say anything about time. So yeah, that's it. Some use cases here if you're interested. Of course, when you see this kind of feature, you think, okay, how can I use it? But it's one more tool in your toolbox, right? When you start mixing this with the other services I'm going to mention, like SNS and SQS, and with Lambda alone, you can do, well, a lot of patterns, serverless patterns, all of them scaling to zero, paying as you go. It can really reduce the cost. As an example, the project I'm working on at the moment, it has a lot of Lambdas. I think it has, it's not huge, but it probably has 300 Lambdas. And well, a lot of API endpoints, 6 DynamoDB tables, with its streams enabled in most of them. It's an event-driven architecture, and it's very cheap. If nobody uses it, I think it almost goes to zero. There are the costs of the KMS keys, and there are other minor running costs that you have for some services. But in terms of scaling and operational costs, it's very low. Okay, so this was the strangler pattern. Let's go to the publish subscriber. It's a messaging integration pattern, in fact. And if you haven't read this book here and you're interested in integration patterns, I know that Fabio is, because I was discussing with him some while ago about architecture and patterns. This book is really good. It's old right now. I think it's from 94, something like that. But the patterns that we use are the same as described here yet. We just changed the tools and we give other names to the same stuff. But there are some things in computer science that just keep for a long time, and patterns really, they work well. So probably you can have a look later. I can share this link with you in the chat. Yeah. There in the table of contents, you'll see there are some messaging systems, pattern, channels, how to construct your messages. And probably a lot of this stuff you already use, but you might not know that it has a name and it's very old. For example, dead letter queues, I think it's in this, is one of these patterns. Yeah. It calls here dead letter channel. So yeah, it's a great book. And if you're interested in newer patterns, I like this website, which is a book as well from Chris Richardson, Microservices IO. And he gives you this map right away as the homepage. And here he mapped possible solutions and trade-offs. And when you adopt a pattern, what other patterns it might imply, because every pattern that you adopt, you create a potential problem. So it's really a trade-off. Adopting all patterns is not good. That's why you may heard that going to microservices blindly is probably a mistake, right? And that's true. Because it comes with a lot of complexity and drawbacks. So it is good to map, this website is good to map. If you could afford a pattern and if you could apply it. For example, API composition is an alternative solution to CQRS here. And when you're doing database per service, it implies that you'll need to adopt one of these two. So if you click here, it will give you a proper pattern format. So context, problem, forces, solutions, and consequences. And I love when patterns are described this way. It's really good. So let me go back to the class. Sorry. Let me share this link with you. Yeah. Yeah, so publish subscriber is a way of decoupling services as well. When there is one service that you call a producer that will publish a message and he's not aware of who is consuming that message, basically. And there could be multiple consumers in this scenario. It decouples services because uh, you don't need to scale consumers on the producer side. So you don't need to have a list of other services you're integrating with. Basically, you publish the message to a topic or a channel. And this channel is responsible for distributing the message for you. It can also do some processing before routing. I'll show you an example of this logic before routing in a minute. But here you can see the way to solve this problem using AWS is by using SMS, maybe, mainly. SNS stands for Simple Notification Service. And it offers a simple API as other services, right? You just need to do a publish message. It will ask for the topic you're publishing to and the message content. Optionally, you can pass some message attributes as the metadata as well for doing some routing I'm going to show. But the idea is publishing to the SNS topic, and here you have service 2, consuming it. It will publish to an SQS queue directly as well. And it can even send an email or an SMS for you. So this SMS feature integration is very interesting because if you worked with publishing SMSs before with Twilio is all right. But I remember one of my first big project that I had, it was in Brazil. It was for publishing SMS and email messages to customers. And we had a volume of about 300 million messages per month. And there was no way to scale, and there was no services like this at that time. It was still progressing, the SNS, but banks were not adopting cloud at that stage. And we connected directly with the brokers, with the carriers. So if you know Brazilian carriers like Vivo, TIM, Claro, yeah, for sending that volume of SMSs, just connecting directly with them. So here you have this option out of the box, this integration, and that's great. And for email, same thing, right? It abstracts a lot of things in this communication. I'll show you, there are other services that SNS integrates with. I think it's a really cool service. Let me show you some more details about it. The same thing as the Dynamodb Streams, it also supports encryption, and it's good to mention. I won't be mentioning for every service because when you're to adopt some service, probably it's one of the first things you're going to look after if you're working in an enterprise. What kinds of encryption does a service offers? What's the data flow that I'll have? Is it just in memory, in transit data, or it's going to be stored there for a while? How long it's going to be stored there? And does it encrypt at rest? So these questions are important. So just to highlight here that it offers encryption. And message attributes, which are these metadata about the message, can be used for filtering. I'll open this to show you. And let me jump to the service in console. So simple notification service. So two main building blocks, topics and subscriptions. The topic is the channel. The subscription are consumers of this channel. So we don't have a list of producers here. Producers, they come from anywhere, any producer that has permission to publish a message to this topic. So I have these three topics I created here. For creating a new topic, it's pretty simple. Let's say class 7. You choose encryption. It supports resource-based policies. So here you can tell who is able to perform actions in this topic, mainly for publishing, subscribing, deleting the topic, changing permissions, but has other services in AWS. It also supports resource-based policies. I'll keep the basic one, which allows any principal to do anything if it's coming from this account that I'm creating the topic. There are some rules for when you're trying to deliver the message to a consumer through the HTTP protocol. You can specify the retry policy it will follow, and back-off mechanism and things like that. Login and tags. So basically, I didn't change anything. I just gave it a name and created the topic. Now I don't have any subscriptions, right? Let's create a new one. And here you can see all of the protocols supported by SNS for receiving a message. So HTTP and HTTPS, you could integrate with any service that exposes some interface using these protocols. Email and email JSON. Native integration with SQS, with Lambda. Platform application endpoint. I don't remember exactly what this is. Mobile application. I'm not sure. And SMS. I don't think it's for all countries in the world. Probably you can check the docs and check for the costs as well, how much it is per SMS, because usually there's a cost for sending that. So if I just choose Lambda here and point it to the same DevOps Academy Lambda that I have there, change it to the subscription, but I'll go back, list our topic. It is there, right? Now, you probably noticed in the project 1 that when you do some things in the console, AWS creates some resources behind the scenes for you, right? And when you jumped into the Terraform code, it was a little bit different. You needed to create some some other resources there that you didn't need to create when you used the console. So the same thing happened here right now. When I created this subscription for the topic, pointing to this Lambda, saying this Lambda can consume messages from this topic, behind the scenes, it came to my Lambda and added the SNS service as the principal, allowing to invoke the function. So SNS as any other principal. If you remember the AIM class, principals can be two main types, if I'm not mistaken. They can be services or from the AWS type. And in this AWS type, you have users, groups, and roles. SNS, as any other service that would invoke this Lambda, it needs permissions to invoke the function. And you need to grant it in the Lambda as well. So in Terraform, if you're coding this, you need to remember to add this permission. If not, when you publish a message, you won't see the Lambda handling it. It might be related to the problem you have there, Amy. Not sure. With the API gateway calling the Lambda.
Not really sure, Dennis. I did add the permission though. We'll have a look. Yeah.
Okay. That's cool. Because I think it's the same concept. The API gateway is going to invoke the function.
Mm-hmm.
So you need API gateway allow invoke function in the resource-based policy. Cool. So I talked about message attributes. So what is that basically, right? If I come here to publish a new message, say subject is optional, time to live is optional as well. Time to live is for when SNS is trying to deliver and it's within the retry periods. Basically, you can discard messages based on the time they are waiting to be delivered. Oh, I forgot to mention, you can also do push notification, mobile push notification, publishing with SNS. So I'll include here class 7, first message. And as a separate piece of data, not directly associated with the body, I can add message attributes. I can say event type, order completed, for example. There are these 4 data types you can choose from. Just one more. Now let me try and publish this message with this body and these 2 message attributes. Okay, it was published. If I had 1 million subscriptions here, right now we would be funding out to this 1 million. I think there's a limit, a very high limit on the number of subscribers. 10 million subscriptions per topic and 100,000 topics per account. So it's, you can handle high volume using it. Let's check the same CloudWatch logs again to see if my Lambda ran. Okay, it seems it ran, so 6:22 just now. And now what I'm getting there, a different event from a different event source, right? And you can see here my message, class 7 first message. If you keep going, the message attributes are delivered as a separate property in this JSON object, right? So that's all fine. But let's go back to our subscription. I won't create it on the fly, but just for you to grab the idea. The subscription filter policy is a way of filtering by subscription some message attributes that you have in the messages, allowing the subscription to receive just messages that matches what you have here in the filter policy. So, quick example, it is JSON. Right. If I come to this subscription for that Lambda, and I know this message was published with, this message is published with an event type message attribute. I can use this event type to say, okay, you are going to run this Lambda, but just when the event type is, I don't remember exactly which properties it needs, but something like that. Just when the event type contains order completed. So you could have subscriptions for several Lambdas. Imagine your system. A set of Lambdas will be handling orders, or the orders subdomain, right? Another piece of the system will be handling stock or credit or card integration, payments, gateways, for example. If you're doing event-driven architecture here, probably you will be throwing events around. So other Lambdas can subscribe to the events and do other processing. So by filtering here using subscription filter policies, you basically can filter by event type in a way that you control exactly which Lambdas need to run at which time. Right. This example I gave is very specific, but you got the idea. You can filter here even by numbers. So let's say if price, I don't remember the syntax, but it's going to be something like greater than 100. I think it's better to use this, these examples here. Message attribute. So you have in the Docker message filtering. There are 2 tutorials here if you want to try later. Subscription filter policies. So the example he gives is message attributes, customer interests, store, event, and price USD. And if you scroll down, you'll see his filtering by price, greater than 100, event, anything but order canceled for that store, and where customer interested is one-off, because this is this is an OR in this filter policy. So customer interest is one-off rugby or football or baseball, basically. If the event matches this, then it will deliver the message to the target. Otherwise, no. I think that's it. Any questions about SNS?
No, good.
Yep. So, all right, so scrolling up again, we were in the publish subscriber messaging, right? So in my example here, I have a queue as a target as well. So moving on, next pattern, persistent asynchronous messaging. This pattern is useful to solve the problem of when you have like a legacy system. It doesn't even need to be a legacy system, but let's suppose you bought a product, commercial off the shelf product, and it does some heavy processing. It takes a while, and for some reason, it's not that reliable as well. It goes down. It takes 5 minutes to come up again. Well, let's suppose it happens. You don't really want to lose the messages that you send to the system. Because the producers, there might be several upstream services, right? So let's suppose the client was there in the browser and they clicked, okay, this is my shopping cart. I added everything I needed. I click order. And the customer expects something like order accepted or some basic validation and saying, okay, we are processing your order. You probably should not return an error because some backend processing happens, and you could have avoided it. Let's say because a payment gateway is down right now, but it will be up in 5 minutes. That's okay to wait 5 minutes to process a purchase, right? It's better than returning an error to the customer and the customer saying, this website doesn't work. Let me go and buy somewhere else, right? So in these cases, you need to persist the request for later processing. And queues are very good for that, usually, because queues are first in, first out, right? And you have requests coming here, and they're getting in the line, usually ordered. And if the producer goes down, and if the consumer goes down, it doesn't matter much because in this case, it is a persistent queue. There are some queues that you can find in some products that are in-memory queues. That's all right. They are volatile. So if it goes down, the queue goes down, probably it won't persist any message it had there. So it's like a buffer, in-memory buffer. So in this scenario here, I'm talking about the persistent queues. So the queues that can storage, they can store the messages with a good SLA. So even if there are problems in the queue itself, it will come up again and the message will be there, right? So here's an example. A service one publishes a message to an SNS topic. And this topic is delivering to two different queues directly. One queue triggers and service 2, and the other queue will trigger service 3. Right? This way, and let's suppose for a minute here that we don't have lambdas on this side, because we know lambdas are high available. If something fails and AZ fails, it will still be there. You can call it. You don't need to worry much about it. It scales very well. But suppose you have an EC2 instance consuming this queue, pulling this queue. If the instance is down and not pulling, the messages will just be there in the queue. And when we talk about AWS SQS queues, you can have, and when I say that, I get a little bit afraid that it might not hold true, but these queues can hold an infinite number of messages. Like AWS says that S3 can scale infinitely. The SQS queue, in this case, the same thing. You can hold any number of messages there. But there are some service limits that I'd like to mention in a minute. So in this common, in this example I'm giving here, for example, if there is an API just behind here upstream of this service 1, the API could return a 202, for example, an accepted status code to the client. And the UI could handle that, saying, okay, your order was accepted and it's processing. Then the UI can pull some other data store to say, okay, your order was processed successfully or with an error. Before going to the SQS service, there's another queue related pattern. Called queue-based load leveling. I think showing you an image will be better than explaining it. But suppose you have a scenario with high volume workload, or you receive just a spike in your requests for some reason. Black Friday is the favorite example of everybody because it's true. And well, there's a surge in your requests that you were not expecting. But unfortunately, you have an application consuming it that doesn't scale very well and can get overloaded. And if it gets overloaded, it won't handle any request at all, right? Like max memory usage, max CPU usage. Basically what you want to do with this line that came like this and just spiked, you want to flat this line in some way. So you keep your service running, but at the pace it can handle. Right?
This is like basically throttling?
Yes, exactly.
Oh.
Exactly, that's correct. So this is the image I'd like to show you. Max throughput here is what your service can afford, basically. And what passes this threshold is going to be discarded. It will create errors, timeouts, and all sorts of problems that you cannot handle at that time. So the idea, as you can see, the red line here, is if I receive too many requests, I stop up to a limit, and all of this additional volume that I have here, it's going to be persisted somewhere temporarily, and when I have capacity, I'll process it and remove from this temporary storage. This temporary storage in this solution is a queue. Of course, you can think about other data stores, right? These patterns is for grabbing the idea, and I'm giving examples using AWS services as well. A queue is not a bad choice. I'm not saying that. It's a good choice, but nothing prevents you from, I don't know, creating files in a bucket and call it a queue or a job pool. You can use any data store. So by how do we get this EC2 application to consume at its own pace, right? Basically, we do it by pulling just the number of messages that we know we can process and at the time we know we can process. As an example, there's an SQS queue and I have 1 million messages there waiting. But I can just process 10 at a time. I'll pull for the next 10 messages. I'll receive them. I'll spend 1 minute processing them. When I finish, I'll remove the messages from this queue, because with SQS, basically you need to tell it to remove the messages there, right? Just by receiving the messages, it doesn't remove the messages from the queue. So after processing, I go back to SQS and say delete message, delete message. Then I pull again the next 10 messages. In this way, I just kept the max throughput of my service up to 10. So 10 would be this line here in this example. And although I have 1 million messages in my queue, doesn't matter, it will take forever, but eventually it will process. All right. It's a useful pattern when you have limitations and you cannot scale well. Maybe you don't have control over the product. You don't have control over other teams' product. So let's suppose, yeah, that's a real case. I think for some reason we were calling GitHub APIs too often, and it was throttling because it was throttling on the GitHub side with a 429 error, too many requests. So we needed to amortize this number of requests to GitHub because we didn't control the settings for the GitHub Enterprise. It was another team's responsibility. So as a temporary solution, we applied this pattern for holding these requests. It was not exactly like this with this queue, but this way we could handle throttling on other team sides, let's say, right? Depending on the settings that they have there, we avoided this throttling of their service. Yeah, I think now we can see some details about SQS. Any questions? Oh yeah, let me jump into the console. I think my section is gone. Okay, so simple queue service.
Dennis, what's like an open source solution that compares to this SQS?
You have many.
Like a RabbitMQ?
RabbitMQ
Rabbit.
would be one. ActiveMQ. In the enterprise, I think IBM MQ is the most used solution yet. What else? Yeah, queues like that. Zero MQ is high performance. There are many flavors of queues there because each one will offer what is a main capability that will vary in fact by product, which is the message delivery guarantees, right? Depending on the solution you need, you'll need to have at least once deliveries, at most one delivery, or 0 or 1 delivery. That's basically the three delivery guarantees that we have in these queues, right?
Right.
Many of them will use at least one message delivery because it's as these queues needs to scale and they need to handle retries, it's hard to guarantee that a message was exactly delivered just once, right? But it depends on your business scenario, really. And the second thing that I think, now there are two more things that are very important when choosing a queue. Protocols and integrations. So probably you have a tech stack already, and you're thinking about implementing queues, and you need to adopt a technology. So what protocols I already have in my application, right? So you can filter by that. For example, if you need to use MQTT protocol, which is a very succinct protocol, the minimum message is just 1 byte. Used for IoT a lot. Not all queues will offer that for you. Just some queues will implement it. And the third thing, maybe the one that people look the most, is the performance, the throughput, basically. And if you look for 0MQ versus RabbitMQ versus ActiveMQ throughput, probably you'll find a graph in no time comparing those. Yeah. Sender throughput, receiver throughput, basically. Kafka is listed here. You can consider Kafka a queue as well.
And Reds. Reds is a key pair storage, right? Like on run.
Yeah, in this is maybe a bad example. It's mixing a lot of stuff here. Yeah, but I think, yeah, you got the idea. There are some nuances between these technologies in this image here, right? Kafka is more of a time series storage. Some people use it as a data data store, and they really persist the data there. Some people used to persist it for 7 days for just doing integration with other services. But the way consumers consume from a Kafka stream is different than a regular queue. Yeah, I think that's it.
Yeah. I could.
Did I answer?
It's good. Yes, it answers. It's good to know because sometimes you have some service with these fancy names on AWS, and we need to have something to compare on the real world.
Yes, and it was a good point because I just remembered that there is another queue service in AWS called Amazon MQ, which is a compatible managed service with Apache ActiveMQ. So if you already have ActiveMQ in your on-prem environment and you want to migrate to AWS, you could just go with Amazon MQ. That will be easier way to migrate to the cloud probably than using SQS. You can import your configurations and everything.
All good.
Yeah. And these queues, they are robust, right? It's not just like SQS. So RabbitMQ, for example, it does pub/sub. So RabbitMQ, it does what SNS does as well. You can have subscribers, you'll have producers, or you can have ordered queues, you can have unordered queues, and which option that you choose will have the trade-offs, right? With the delivery guarantees and throughput. So let's create a queue here in SQS service. First thing you see, there are two types of queues you can create. Standard queues, at least once delivery. Message ordering is not guaranteed. It is just best effort. So yes, you can receive the same message more than once. And if you send 1, 2, 3, you might receive 1, 3, 2, 4, for example. The other type, FIFO queues. First in, first out delivery with ordering. Exactly once processing. So basically it's guaranteing that it will not duplicate your message and will deliver just once to the target you chose, basically a Lambda, for example, right? Let's create a standard one. And here there are 5 configurations which are important. And it really depends on what you're trying to achieve with this queue. If I just go back to our pattern and we want to implement this pattern here, right? A slow consumer, pulling messages, 10 at a time, and that's all. No other requirements on this, right? We could come here and just say, okay, visibility timeout. How long after receiving this message, should this message be not visible to other consumers? think that instead of having just one EC2 here, that we have two EC2s here, both pulling from the same queue 10 messages at a time, right? Maybe it's easier if I show you this. Yes, yeah. So those configurations there, some of them are depicted here in this image, right? So my service one came here and sent a message using this send message command. The first configuration we see here, in fact, is what's the delay for this message to be visible for consumers. And this is the configuration you need to set. So if you want to delay the time the message will take to be visible, you can just set here in seconds up to 15 minutes, right? If you're doing some kind of loop, SQS queue calls a lambda, and the lambda inserts another message in the queue, and it's like that invokes the same lambda. There are all kind of crazy stuff there. You might think about working with this delivery delay. So what I said, it's totally possible, right? If you just create one queue and one lambda, and you say for the lambda to pull from the queue, and the lambda logic, you insert a message back to the lambda, what is that, right? It is an infinite loop, right? So there might be a reason for that. Maybe you're doing a cleanup process, you're doing a restart process, whatever you need to do. And if you want to control the delay in the message, you could use this configuration. Passing the delay in seconds, that can be 0, right? If you don't need it, just set it to 0. And when you send a message, it will be available right away. After being visible, this message can be received. So any consumer allowed to receive a message from this queue can just call the command receive message, and they will receive the number of messages they are asking for. So up to 10, right? So you cannot consume more than 10 messages at a time from a queue, right? If you want to process 100 messages, you need to include this logic in your application code, and just do a like for loop or something like that, and go 10 times to the SQS service to grab 100 messages. So you're calling receive now, and you just received 10 messages. SQS will start as soon as it delivers the messages to you, or in fact, just before delivering the messages to you, it's going to make those messages invisible for, not visible for other consumers. And this is what is called visibility timeout here, which is basically the amount of time that SQS will hide those messages from any other consumers. Let's say 30 seconds. So you received the message and you're processing here during 30 seconds, and now 40 seconds, you're still processing, and the visibility timeout is over. What will happen here? Any guess?
Yeah, it will come back to the queue and someone else can consume it again. And yeah, it's a problem.
Yes, exactly. Exactly. As soon as the visibility timeout is over, SQS will make the message visible again. It doesn't matter if you're still processing, it doesn't really care because it's not aware of your application processing. And unless you come and delete the message from the queue, because the message is there, right? It's just not visible. Right? So your application needs to come back and delete message. It's a command, right? As soon as you finish your processing, you need to delete explicitly the message. So, well, so it's gone and it doesn't appear to anybody else anymore. So this is the visibility timeout, and the max is 12 hours. So yep.
So the default behavior is your app, like your function, should consume the message and delete the message.
Yes.
Ah, good. Thanks.
Yeah. Not all queues work this way.
Right.
Probably you may know a queue that when you ask for messages, it already removes the message from the queue.
That's so good. I got it. The case of SQS, when I consume the message, I have to delete the message to do it. Like sorted. This message was consumed, deleted.
Yes.
All right.
Yeah.
All right.
And well, this is the visibility timeout, the time that message is hidden. Up to 12 hours, what means that if you are still processing the message and the visibility timeout is almost over, you need to, wow, I forgot this one, Kiko and Kyle. It is, I said that because it is a famous certification question, I think, for the solutions architect associate. When you're still processing the message and the visibility timeout needs to be reset, you need to set it to 0, right?
I don't have experience with SQS, sorry, can't help.
Okay, I forgot about that. But if anyone is interested, I can research that later. So there's a way of just going back to SQS and resetting the visibility timeout for the message. It's like saying, oh, I'm still processing. I don't want to change the configuration, but just for this message, it's taking longer than I expected. So keep it not visible for other consumers. Right? Message retention up to 14 days. So this is a persistent queue, that's true, but up to 14 days. If you didn't process it, like in my example, you had 1 million messages processing 10 by 10. It won't finish, I think, 1 minute every batch. Yeah, I don't know. If it doesn't finish in 14 days, they're going to be discarded. Maximum message size up to 256 KB. If you need to handle bigger messages, consider using S3 for storing your payload. Let's say you have a payload of 500K, right? You can use S3 for a temporary message storage and just include the message in the SQS queue with a reference to your message payload path prefix, right?
Yeah, we do that at work, like to integrate all the logs. All the logs are residing in the buckets, and then the queue is there to provide just the metadata, like the key and the bucket name and whatnot.
Cool.
Yeah.
Nice. And the last one of these 5 is this receive message wait time. And this one is used for long pooling, basically. So suppose you have a queue, but there are not many messages there. Let's suppose it is empty. And you receive a message at a rate of, I don't know, 5 messages per minute. But some minutes, there are minutes that there are no messages there coming. In some minutes, you receive 10 and so on. So for avoiding pulling too frequently the SQS queue with empty responses, right? You can set this receive message wait time to up to 20 seconds. So basically, the command will trigger a request and holds and waits for at least one message to be available in the queue before returning within these 20 seconds. This is called long pooling. And it's mainly for reducing this waste of time and overheads of going back and forth with empty responses, right? Okay. Okay, that's it about SQS. Any other questions? I think I'm almost finishing, guys. Should we go on instead of during the break? Yep. Green? I don't think so, right?
Yeah. No, we can see it. Yep.
Okay. It's probably frozen.
Oh, maybe it's. Oh, no.
That's okay.
Oh, it's going well, right?
Yep.
Cool. So let's go on to the last, I think last 3 patterns that I listed here. First one, I called it flat files integration. It's a file transfer integration. I included a reference to that EIP book. It's an old way of doing integrations, but sometimes it's needed yet, depending on the volume of the data you have, or when you're integrating with other systems. I know in the banking area, when you have integrations with applications running COBOL, and they just run these jobs and create a bunch of files, and you need to integrate by consuming those files, and you create files back so they can read from the files. It's a common pattern. Also, you can call the IMS transaction directly, but it's a way of doing integration for sure. Of course, we are changing these technologies now, and when we talk about files, the first thing that comes to mind is the S3 service. So when we have files created, updated, or deleted in S3, there's a feature we can use called S3 event notifications that we can configure to notify lambdas, SQS queues, or SNS topics about these changes, right? So in this image, it's pretty simple. And it's simple as that. In fact, you have an S3 bucket. And when I upload a file here, for example, I configured this event notification to call Lambda for me. If we jump directly to S3 to see what it looks like. You need to go to this tab, Properties, scroll down, and you'll see Events. If you click here, you can add notifications. The feature is called Event Notification, so it uses these terms interchangeably. You can create several notifications for a bucket. It is in the bucket level. And when you click Add here, it will ask you which events do you want to track and create events. And here you have the put, post, and copy events. Or instead of selecting individually, you can say all objects create events, for example. So it has these options with aggregation of operations for you to choose. And object delete events, for example, when an object is deleted in this bucket, as it is a critical bucket for me, for example, with sensitive information, I need to add one record to another trail somewhere else. So you could use these all object delete events, for example, for that. And, well, other options here. If you want to track a specific prefix, it looks like a folder, right, in S3. You could say, for example, my sensitive data. So anything starting with the prefix my sensitive data and with suffix txt, for example, or log, any suffix of the object, it will match this rule, right? And you can send to one of those three targets we talked about. So I'm going to choose again my Lambda. I will remove this just to keep it simple. Maybe, nah, that's all right. Simple filters, right? Yes, all object create events, call my Lambda. Oh, okay, I already have an event matching the same events. So it is refusing to create another. So per event type, you can have only one Lambda as a target for those events, right? So all create events. All create events. Do not filter by anything. Lambda and my Lambda. Okay, cool. Again, AWS behind the scenes did some magic and added permissions. And guess what now? For S3 to invoke the function, given the ARN is for this S3 bucket that I configured, right? If you're doing it in Terraform, you need to create this permission and attach to your Lambda. So let's see if it works. Let's try to upload something, and hopefully we can see the logs in the bucket, in the CloudWatch logs. DB stream, yeah, this one should work. Upload, yeah, upload was a success. Let's go to the Lambda, CloudWatch. Is this my event? Yes, it is. Demos are working today. I don't know what's happening. So you have an event here, event source, AWS S3. It was an object created, put, right? And the information it gives you, it tells you the event notification name. And somewhere here, yes, here, we can see the object created. So here, as I just uploaded to the main level of the bucket, right? There's no prefix behind it. It's just saying that the key is my file name. But if you had several levels here, the prefix would be, well, my sensitive data / something / something, then the object name. Cool. Then when I received these events here in Lambda, well, this info is available to me. I can just go ahead, maybe fetch this object and do whatever I need to do. It is a common pattern for image resizing. So if you have a website or mobile application and you need to handle several thumbnails for different screen sizes, you just you can just ingest the customer avatar photo. For example, the person goes there, uploads. I uploaded my photo, and this photo is added to the S3 bucket, which will call the first Lambda, and this Lambda could potentially invoke other Lambdas and other services for creating thumbnails for specific sizes and making them available to the clients, to the application. I think that's it. There's to it. Any questions about this S3 event notifications? No? Cool. Before going to the last one, I'd like you to just think for 1 second how you could mix these patterns, because I'm showing just some broken pieces to explain the pattern and the technology as well. But for example, this flat files integration with S3 S3 delivers to an SQS queue as well. So we could potentially leverage these two patterns, right? Let's suppose I don't have a Lambda here, but an EC2 instance like I have just above. So I could do S3, Q, then EC2, right? Let's suppose when an object, extending further, when I upload an object here, and I have the Q and the EC2, I also need to invoke a Lambda to send an email to the customer saying, thank you very much for uploading your avatar photo. How can I invoke, how can I send an event about this object upload to the queue and at the same time to a Lambda if just one target is allowed, right?
Yeah, this is when the SNS and then from SNS, bunch of SQS subscribe to SNS.
Perfect.
Fan out.
Yeah, exactly. So basically the problem, you need to frame the problem with the patterns you have in your toolbox, right? Okay, I have one producer, but natively it just integrates with one target. I like to fan out this message to more consumers. So fan out, so subscribing consumers, producer, publish subscriber pattern, for example. So the S3 bucket would be here. You publish directly the event to the SNS topic. And from the SNS topic, you have there a path, one subscriber going to the Lambda and the other subscriber going to the queue. And from the queue, you have the EC2 pulling it. And this just goes growing and growing. That's why we break this down and we split by context and call it microservice. Basically, we just group the things that make sense for business domains, and we can group and understand together because it's hard to understand everything. There are too many moving parts at the same time.
And probably that's why the S3 bucket doesn't allow you to connect to other sources at the same time, because they have the SNS that does that. So
yes,
they're not gonna put two things separate, I guess.
Yeah, that's true. So yeah, the service is already considering that, you know, what you can do with these other services that are listed here. That's true. Yeah. Okay, now we can move on to the next one. Schedule jobs. I think the name says everything. I'll talk about schedule jobs and event triggers like together, because the service that will help us with that is the same one, which is CloudWatch Events, now named Event Bridge. I think AWS is phasing out the CloudWatch Events name to Event Bridge. It's what the documentation says, at least. And Event Bridge is the preferred service for doing the same stuff, right? So they're adding features in Event Bridge, but they're still supporting the backward compatibility with CloudWatch Events. So you can still go there and do some, you can use some features, but the new ones will be just in Event Bridge. So this schedule jobs pattern is basically the cron jobs that you used to have for doing recurring tasks, right? It's a job that you can say maybe the frequency it runs or the time of the day it will run. And when it matches that schedule, it will trigger what you asked this to invoke. The same functionality you have in CloudWatch events. You can use even the same definition of the cron job of a cron job like that. Yeah, you can use a website like this cron tab guru or any command line too. But the idea is that here you specify some periodicity for something. So this string here, it means at 1 minute, right? This one means at every minute. So if you want something to run at every minute in a cron job syntax, you just need to use this string.
Hey, Dennis.
Yeah.
Just one thing, man. I know this is AWS focused, but if you have to do this for Azure, like the cron job is different. So this one won't work there. The syntax, I know it sounds ridiculous, but the way it's formed is a bit different.
Oh yeah? I didn't know that. That's interesting. But
So,
they call it, do they call it cron?
Yeah, so that means that Azure doesn't use Chrome, right?
No,
Yeah.
it is wrong, but this specific website won't work in Azure.
Yeah, but
Cron is a standard. Cron is a Unix
Yeah.
standard.
Because this is a cron expression.
Wow.
Just use a different approach. Is not cron job, Unix cron job. That's it.
This website that I use, Azure Chrome something, it's the same thing. That's
the same purpose. You define a periodicity to trigger something.
Yeah, that is this online tool calculator that's specific for Azure. So if it happens, one of you guys need to use this for Azure. Like a normal Chrome may not work. Just this. Yeah, that's it.
Thanks. Good to know, man. Yeah, that's it about Chrome. I won't spend much time here. So let's just jump quickly to CloudWatch events and Event Bridge. You can see here there's a warning in their page. So you can access by typing CloudWatch and coming to this tab here, Events and Rules, or you can access Event Bridge directly. They're fully compatible. So creating a rule here is the same as creating a rule there. If I click to create a rule here, which is the main building block behind events, you'll see there are two main patterns you can define, an event pattern or a schedule. And the schedule can be at a fixed rate every X minutes, hours, or days, and AWS has this nice interface for helping you with that, or you can come and just define the cron expression the same way we just saw, right? Going forward, after I defined the periodicity that I want to run it, I need to define my targets mainly. So what are valid targets for CloudWatch events? For this one, you have a nice list, right? So API gateway included. We didn't see code pipeline, but when you do a commit push using code commit, which is the Git managed service in AWS, if we use the CloudWatch events for triggering the pipeline, if you configure it this way. ECS task, Kinesis stream, Lambda, SNS, SQS again. And just with these two, you can do a lot and other services. So a lot of options here. All right. And after configuring that's enough. So for cron expressions, if you want to run a Lambda every 1 minute, all you need to do is come in here, configuring a new rule, cron expression, or this other option for fixed rate, and your Lambda here. And don't forget about the permissions again, right? S3 needed permissions to invoke Lambda. API gateway needs it. SNS needs it. And the same thing for CloudWatch. They need all invoke function permission. Just jumping back quickly here to the event triggers, which is pretty similar. The event triggers are jobs triggered, but this time not by time or periodicity, but by an event created by another source. In this case, the source can be AWS services, and you have several options. I'm going to show some of them for you, or your application. There might be a service that you hold that will create events, and another service is going to be triggered by these events directly. It's an integration different than using SNS, for example, right? It's a direct event integration in this case. But the idea is the same. Anything matching the pattern would be invoked. So jumping into the console again, same screen. Let's come and create a rule. Let's call it all about EC2. And this time, let's choose event pattern. If you want to do something like I just mentioned, specific events created by your application, you'll need to go with this custom pattern. Then you can define your own pattern. But if you just want to consume AWS events, you can choose the predefined ones. And here you have two options, AWS events or service partner events. In AWS, you have several events to listen to and filter. So API, S3, you'll find many, I don't know if all of them, but there are a good deal of services here listed. Let's have a look at the EC2 events. If I choose EC2, I have these events listed, which are built in CloudWatch events for me. So if I want to know every time an instance state change, for example, so what is an instance stage change, right? The state of the instance is basically stopped, running, terminated, pending, and so on, right? So every time this state changes for any AWS instances, because as you can see here, the pattern is not specifying anything else. It will match and trigger my target just below. If I want to be more specific, I can keep adding details here, right? An instance with a specific name, for example, or specific attributes, for example, right? Just using the default one. For EC2, it has even some nice UI drop-down boxes for you. You can keep going configuring, but be aware that's not for all events. And in the end, we'll need this JSON with the event pattern. Right? It's just helping you to build this pattern. And instance, and you can choose it here. That's all right. Okay, end state. So I'm going to use the default event bus. I won't get into much details about event buses, but you can have several buses. And when you publish an event, you need to point to an event bus. It is your channel, the same idea of the EIP book that I showed before. You need a channel to transmit the message. In this case, it's an event bus. As a target, I'll choose my Lambda function again. ECS task can be the target, just out of curiosity. Lambda, yeah, and create. Okay. Now I have my, where is it? All about EC2. Yeah, it's here and it's enabled. You can quickly disable it if it's causing problems or something like that. So just to close this demo, let's go ahead and do the same thing that we've done for other types of integration. Let's do the thing and let's see the events that Lambda is receiving. So I'll use one instance template that I have here for not configuring everything again. Okay, it's launching my instance. Okay. Yeah, probably it is enough. I have some automation here. It is an exercise for you guys. It's an interesting one because I'm shutting down any instance that runs without the tags that I chose as mandatory. And in this case, it is cost center. So if someone launches an instance without a cost center, I just shut it down and say invalid tags in the name. That's why it was starting and just came down. But probably it is enough for running our Lambda because the instance state changed, man. So let's see what happened. Let's go to the CloudWatch. Okay, so is this my events? Probably. I have one, yeah, probably I have several events here. 7, 42, 30, 36, 38. So let's have a look at the last one to start with. So yeah, as expected, the last event I received was exactly instance ID. Well, first the event source, right? Event source AWS EC2. Detail type EC2 instance state change notification, exactly the one that I specified there. And it gives me the ARN of the instance. And in the detail, I have the JSON broke down with the instance ID and the state. So I know this instance was terminated. If I get the one just before, it was shutting down. Okay. And the one before, is this from today? It is terminated. Okay, I think it executed twice. I have other rule pointing to the same Lambda. So as I have two rules, right? It matched twice and it delivered to the same target. That's why it's duplicated here. So this is the Lambda that's shutting down the instances, in fact. But if I open another one just here, you can see it was impending. So the main takeaway is that you can match several events from AWS. You don't need to code them. They are available to you. And you can do automations using these events out of the box. This one of shutting down instances is a classic power management scenario. And when you have instances used for development only, probably you need to stop them. Yeah, you need to stop them out of business hours to save some money. So you could do that using the cron expression, for example, for shutting down all instances tagged with a specific tag when it is 7 o'clock p.m., for example. Okay. Any questions on the CloudWatch events?
Not yet.
No?
No, good.
Oh, yeah, that's basically it that I had today, guys. So do you have any questions about the content as a whole?
Are you going to merge this? You are working a new branch, right?
Yes.
Oh, good.
Are we, Kyle, Kiko? Depending on the approval, we need to review it yet. But yes, it will be merged by tomorrow, I think. I just saw the poll. Someone remembered this time. Okay, yeah, that's good. Thanks for that. Yeah, guys, if you can just answer that, that helps us to understand how it went. And meanwhile, I'll show you the exercises. There are just two. One of them will use the exercise from class 6. And the other one you can do without any other dependency. So the first one depends on class 6.
These exercises are not there in the master branch, I believe. Okay.
Not yet.
Not able to view them.
Yes, yes. probably by tomorrow.
Okay.
So in this exercise, I just gave the requirements and it's up to you to implement the solution. Well, I gave the solution as well, but I didn't give all the source code. So this is what you had in the class 6 exercise in API, Lambda, Dynamo. So I'm asking here to when you, I need to fix the wording here, but the idea is when a user comes and uploads here an image, which name is the email address that they have here in this first step recorded. I'm just using the email address to simplify the codes, right? So I uploaded here dennis@gmail.com. It will trigger a Lambda. And I'm asking here to reply to the user saying, thanks for adding your awesome photo using the SES service. We didn't see it, but don't worry. It is a service for sending emails. It is as simple as passing the person to receive it and the message itself. It's pretty simple. And also change the record in Dynamodb with the photo location. So if I upload it here in my bucket to the images folder, for example, it will be in Dynamodb in that specific line of my email address, images/dennis@gmail.com.png, for example. After uploading this photo location, we'll need to let the admin knows how many rows are in the customers table. I just came up with this requirement, right? So you'll need to use Dynamodb Streams here to call another Lambda. This Lambda, in fact, there's an error missing here. It will do a query to your Dynamodb just to count the number of items and publish to an SNS topic, which an admin email, your email here is subscribed. So what happens as a whole, right? When someone uploads a photo with his email address as a name, they should receive an email, their email address saying thanks. And the admin should receive the number of customers in the table. Customers, number of records, X, 13, then I upload a new one, 14, 15, 16, and so on. This is a simple, the use case is not that good, but the idea of the integrations, I think it works. So this one depends on the first exercise, right? The other one is simpler and probably it's better to solve this one first. It is exactly what you saw. If an EC2 is running and it's not tagged with cost center, any value, right? I'm looking for the key cost center in the tags, then terminate the instance and notify the subscribed admins. I think I need to remove it. If not, it will depend on the first exercise. I'll remove this last part here. So if you launch an instance, just terminate it. That's enough for this exercise. And the output for this will be the Terraform code configuring the CloudWatch rule, right? I'll specify it better. Solution will include a CloudWatch rule. I'm giving you the rule here, and I'm giving you the Lambda source code as well. So for this one, you don't need to code anything. For the first one, you need to do some coding in any language, Python, Node.js, you choose. So for this one, I'm giving the Lambda in Python. Read through it. If you have any questions, if you're interested in the Bodo 3 library, just reach out. I'm listing the instances with the status running. I'm parsing all instances which doesn't have the tag. I'm using James Path for it. And if some of them don't have the tag I'm looking for, I just go ahead, terminate the instances. And that's, well, I'm publishing to the topic here as well. Okay, so I need to keep that email part probably. I'll remove it, Don't worry guys, it will be mastered tomorrow. All good, reviewed. You start with the second one, it's simpler, then you can go to the other one, it's more complex. If some of you happen to finish it, and I hope so, that would be good to have someone to present us next class quickly, just for us to see how it works. Cool, I think that's it.